Hello and welcome. Thank you for joining us for today's webinar. We're excited to have you. Our topic is how Purge and Trap plays a key role in Title 40 CFR Parts 136 and 141. Our presenter is Amy Nutter, Technical Product Specialist. If you have any questions, please feel free to submit them throughout the presentation or email Amy directly and she will follow up with you after the webinar concludes. This webinar is being recorded and will be available within a few days. Now I'll turn it over to our presenter, Amy Nutter.
All right, thanks, Shelley. Hi, I'm Amy Nutter, Technical Product Specialist for the Purge and Trap product line here at Teledyne Labs. So like Shelley mentioned, today I'll be going over how Purge and Trap plays a key role in Title 40 Code of the Federal Regulations, Parts 136 for wastewater and 141 for drinking water. So thank you for joining me today. I'll go over a quick introduction to Teledyne Labs and our TechMar products. Then I'll get into what Purge and Trap is and how it works, an introduction to 40 CFR, Parts 136 and 141, including what Purge and Trap methods are involved and the challenges with these methods, and then some tips for a successful analysis. So be sure to submit any questions that you have and I will be able to answer you by email. Teledyne Labs has been around since the 60s, creating the first commercial Purge and Trap concentrator in 1975. We're celebrating our 50 years of Purge and Trap this year. We are the market leader for Purge and Traps in the U.S., and we offer several different options. The Lumen Purge and Trap concentrator, shown on the right, is our standalone waters-only concentrator that can be paired with the Aquatech LVA autosampler. We also have the combined auto sampler Purge Trap concentrator, the Atomics XYZ, shown on the left, and that is capable of analyzing soils, solids, and water samples. We also manufacture other elemental analyzers as well. So Purge and Trap is a technique used to improve the sensitivity of volatile samples analyzed by a GC and their detectors, such as a mass spec. And it goes beyond the capabilities of other traditional preparation methods like static headspace and liquid injection. So now let's get into how this works. So Purge and Trap works on a purge equilibrium theory. So volatile compounds of interest, or compounds that prefer to be in that gaseous phase, they migrate from the liquid or the solid phase to the gaseous phase and are continuously swept away from that headspace in the sparger or in the vial, depending on the method, onto the trap where they are concentrated and then released to the GC. In the case of static headspace on the left, samples come to an equilibrium. The compounds of interest go from the liquid to the gaseous phase, and then when no more net transfer is occurring, an aliquot of that headspace is taken and analyzed. If not enough sensitivity is reached during this static headspace, then that's where Purge and Trap can improve. On the right, we can visually see that purge equilibrium theory happen. The VOCs are moving into the gaseous phase, are continuously being removed by the purge gas. So continuously replacing that headspace causes a higher concentration of VOCs in the liquid phase than in the gaseous phase, creating that net movement of VOCs from liquid to gas, extracting the VOCs from the sample more efficiently and improving sensitivity because there's just more of those compounds to analyze. A basic Purge and Trap consists of 5 main parts: sparger, flow control, 6-port valve, analytical trap, and the heated transfer line. The sparger is the glassware on the front of the instrument that receives the liquid sample to be purged. So purging the sample extracts the VOCs by dispersing inert gas through the sample matrix for a preset time and flow. This flow is controlled by a mass flow controller or a pressure regulator that monitors and precisely controls the gas flow rates throughout the entire Purge and Trap process. From there, the 6-port valve directs the gas containing the analytes to the analytical trap for concentration. The analytical trap is used to capture and release VOCs swept out of the sample by the Purge and Trap. So trapping the VOCs helps create a smaller band of analytes traveling to the GC column, producing greater signal-to-noise ratios, lower area-to-height ratios, and generating sharper peaks and better sensitivity and resolution. Once the VOCs are captured, the trap is heated and carrier gas is backflushed through the trap, causing the VOCs to desorb. The 6-port valve then directs the VOCs through the heated transfer line to the GC for separation and detection by mass spec. So let's get into what we will be discussing today. So Title 40 Code of Federal Regulations, or 40 CFR, which is what I'll refer to it from now on. So in the U.S., regulations are codified or arranged in a certain way every year in the CFR. So Title 40 is for the protection of the environment, which U.S. Congress authorizes the Environmental Protection Agency, or the EPA, whose mission is to protect human health and the environment, to write regulations that explain the technical, operational, and legal details necessary to implement laws. So this can apply to individuals, businesses, state or local governments, nonprofit institutions, and others. The EPA also provides tools you can keep track of and participate in the development of these new EPA regulations and how to comply to existing regulations. So 40 CFR is one of those tools. And I just wanted to briefly mention the Federal Register, because that is different than the CFR in that the FR, the Federal Register, is the official daily publication for rules, proposed rules, and notices from the government, and announces ongoing activity of the agencies, and notifies you when you can comment on a proposed regulation. So EPA rulemakings can impact you once they're final, but until they're finalized, you have the opportunity to provide input before it is codified into the CFR. So 40 CFR Part 136 is for wastewater, and it includes the guidelines that establish the test procedures for the analysis of pollutants in the environment. The EPA uses the procedures to regulate how industries and municipalities analyze wastewater and other environmental samples, and they require to do so under the Clean Water Act with the National Pollutant Discharge Elimination System. So the NPDES permit program is the national system for issuing permits under Section 402 of the Clean Water Act, and it addresses water pollution by regulating point sources that discharge pollutants to waters of the United States, so like industries, municipalities, and so on. Part 136 identifies the test procedures and approved methods for pollutants in wastewater. So the EPA methods that use Purge and Trap that are part of Part 136 are US EPA method 601 for purgeable halocarbons, 602 for purgeable aromatics, 603 for acrolein and acrylonitrile, and 624.1, which are just purgeable VOCs by GCMS. There's a whole list of compounds. And then there are also standard methods that include the Purge and Trap in Part 136, and that would be 6200C. In other sections of Part 136, they discuss how to get alternative test procedures approved, method modifications approved, and analytical requirements for those modifications. You know, if a method is modified, it must meet or exceed the performance of the approved methods for the analytes of interest, and those would be the QC requirements that we will discuss in a few slides. So allowable changes by Part 136 as it pertains to Purge and Trap would be the ability to change GC columns or oven temperature programs, changes between automated and manual sample preparation, so such as digestions, distillations, and extractions, and inline sample preparation is an acceptable form of automated sample prep for the Clean Water Act methods. Changes in calibration range, so provided that the modified range still covers relevant regulatory limits and the method performance specs for calibration are met. Changes in the calibration model or the fit, use of selected ion monitoring or SIM mode for analytes that cannot be effectively analyzed in full scan mode or reach the required sensitivity. Changes are allowed in Purge and Trap sample volumes or operating conditions, and some examples are changes in the purge time and purge gas flow rate, sample temperature during the purge state, so heating of the sample during purging can increase the purging efficiency of those compounds, shortening the desorb time or shorten overall sample cycle time, and reduce water transfer to the GCMS. Dry purge can also help improve moisture management. So choice of using nitrogen or helium as a purge gas, and I can show you a comparison on the next slide. Trap sorbent, so any trap design is acceptable, provided that the data acquired still meets all the QC requirements. And then lastly, if the characteristics of the wastewater matrix prevent efficient recovery of organic pollutants and prevent the method from meeting QC requirements, the analyst may attempt to resolve these issues by adding salts to the sample, provided that the salts don't react with or introduce the target pollutant into the sample. All right, and here is that overlay of helium versus nitrogen as a purge gas. So underneath the red is black, which is their helium purge gas, and then on top is the red, which is the nitrogen purge gas. And as you can see, they overlay quite nicely. In our purging traps, we have the option in the configuration to purge with either helium or nitrogen. And if you need to conserve helium for your analysis, nitrogen provides more than adequate results for those standard EPA methods while purging. So generally for wastewater purge and trap analysis, if it's more of a water matrix, you could have some particulates in it, but it's mainly water. The sample size you want to use is between 5 and 25 mils, depending on the sensitivity that you're trying to reach, and you can purge with a fritted purger. If there are more particulates in it, you're going to want to use a non-fritted spurger so you don't clog up that frit. Purge time and flow rates are set at 11-minute purge at 40 mils a minute, and you can purge with either helium or nitrogen. If the sample has more particulates in it, or if it's more of an industrial sample, you will want to use that fritless spurger and have a foam sensor and even the eliminator if that is a concern, because you don't want foam to get, or anything from your sample to get up into the sample mount of the purge and trap, because it could contaminate your entire system. These methods go through your typical US EPA quality control requirements. So validating the calibration curve, you need to have method detection limits. You need to have that initial demonstration of capability that you can accurately run your samples and quantify them. Continuing calibration checks make sure that calibration curve is still good, and BFB tune checks to make sure your whole system is running well. There are several challenges that can occur with these methods. So there are sample matrix issues. Always moisture management is always a concern with Purge and Trap and carryover and contamination. So sample matrix issues, wastewater samples tend to be a more complex matrix, like a combination of solids or particulates and volatile compounds, which we're interested in. But there could also be semi-volatile compounds in that mix, in that sample, that can build up over time in the gas pathway as they're purged out of the solution, and then they're kind of deposited inside the Purge and Trap system. As these start to build up in the gas pathway, the parts of the system we don't normally consider a consumable can cause active sites where reactions can occur and cause, adsorbents, where some of the compounds of interest could get stuck or hung up, and they could be re-released into the next sample or the sample after that, or they could just make compounds disappear altogether, and we see a suppression of the actual concentration that's being passed on to the detector. So we really have to be careful, what we're purging into our system. If too much water is being transferred to the GC, that can impact sensitivity and cause analytes to collude and have poor peak shape. Here at Techmar, we have a moisture control system on our Purge and Traps, which really helps with the moisture management, and you can optimize those dry purge and bake settings to really help reduce that water vapor. And then, of course, being able to clean up the system between samples and after higher level concentrations is critical. Both of our systems provide hot water rinses between samples, and of course an efficient bake cycle can really help greatly reduce or eliminate carryover between samples. So some tips for a successful wastewater analysis, especially for carryover and contamination. Not only do we need to keep up with routine maintenance, such as trap and sparger maintenance, but also that mass spec source cleaning, GC column trimming, and inlet maintenance, and most importantly, how we are cleaning up the system between samples. So our Purge and Traps offer water heaters that can heat the rinse water up to 90 degrees C, and you can do up to 3 rinses. When you're dealing with these wastewater industrial type waste samples, a great practice is to pre-screen their samples to figure out what you're getting into as far as concentration. This can also give us a hint how often we're going to need to clean and maintain the systems, and when to replace consumables. As a bonus, you can pre-screen the sample. It needs to be diluted. You can just put it on the Atomics XYZ, which can perform automated dilution. So if the sample needs it, the Atomics XYZ can just auto-dilute it. You don't have to do it on the benchtop. The moisture control system, which I've mentioned before, it helps reduce water vapor before it gets to the GC. But we can also remove moisture from sample to sample by choosing efficient bake parameters. A good bake removes the moisture that has accumulated in our system during the Purge and Trap process, so it's ready for the next sample. So on the GC side of things, we can also look into the split ratio. A low split ratio allows a lot of water to get onto the column. So less water going to the GC column means less water getting to the mass spec, which can help extend filament life and allows for less source cleaning, which I know would be a huge time saver because cleaning the source is a long process. And as you can see on the right, we have a 20 ppb 624.1 standard showing minimal water interference at the beginning of the tick and very sharp peaks, from the middle to the end. And that can be attributed to our moisture control system trying to pull out as much moisture from that sample before it reaches the GC. And also our Techmar number 9 trap, which is sent out with all of our units. So having the correct trap for the method you're running is key. So this trap is great for your standard US EPA methods. You just want to make sure that your trap is reaching temperature to ensure that all those target analytes are desorbing off the trap, and you could see, issues like low recovery or carryover. If your trap is not reaching temperature, you can see issues like that. All right, so 40 CFR Part 141 establishes primary drinking water regulations by the Safe Drinking Water Act and regulations acceptable to public water systems. So this part also describes the analysis of listed contaminants for the purpose of determining maximum contaminant level goals and maximum residual disinfectant level goals for your total trihalomethanes, the disinfection byproducts that happens when you're trying to clean up your drinking water and it goes out to the public, to lead to establishing maximum contaminant level compliance in groundwater, surface water, and systems that draw water from multiple sources. So this part goes over sampling, analytical requirements, contaminant sources, and public health effects. It also goes over how to notify the public, because there is that requirement when there's a violation of that maximum contaminant level or the maximum residual disinfectant level, treatment technique, monitoring requirements, and testing procedures. Those are all part of 141 as well. So US EPA methods in Part 141 that use the Purge and Trap would be 502.2 for drinking water VOCs by Purge and Trap with a POD or ECD. 524.2 and 524.3 are measurement of purgeable organic compounds in water by GCMS. 524.3 just allows you to modify more Purge and Trap parameters, and has a little bit shorter of a list, but it also has very strict QC requirements. And so along with 524.3, 524.4 is the same, but it allows you to use nitrogen as the purge gas. In order to stay in compliance and receive certification, laboratories need to analyze performance evaluation or PE samples provided by the EPA, the state, or an approved third party at least once a year by each method for which a laboratory desires certification. So that is another big part of Part 141. So most drinking water methods specifically require a 5 ml sample size, but some of the older methods allow for a 25 ml sample size, which can help you achieve low level or parts per trillion analysis, but it does transfer a lot of water to the GCMS. So drinking water methods require sample chilling from the time it's collected until analysis, so between 4 and 10 degrees Celsius. Or some drinking water methods parameters aren't allowed to be changed from what is suggested, like having a purge for 11 minutes at 40 mils per minute with a 4-minute desorb, like 524.2, which does allow a lot of that water to get to the GC inlet and onto the column. And that is because with the technology at the time that these methods were created, those parameters worked best for the system because they weren't as sensitive as they are today. And like I mentioned before, there are updated methods like 524.3 and 524.4, which allow you to optimize purge and trap parameters to maximize purge efficiency and minimize that transmission of water to the GC. So the 5 key parameters that you can change are the sample temperature, purge flow rate, purge volume, desorb time, and the purge volume plus the dry purge volume. So you're able to run samples quicker and more efficiently, decreasing sample cycle time and being able to run more samples within that analysis shift. So most drinking water methods specifically call out helium as a purge gas. And then, like I mentioned, 524.4 allows for nitrogen as the purge gas, saving on that expensive and increasingly hard to source helium. So some of the challenges with drinking water methods. So reproducibility. If internal standard concentrations aren't consistent, or if there's an active site, then it can cause issues with linearity and recovery of your analytes. Carryover and contamination. So being able to clean up the system between samples and after high level concentrations is critical, especially for those that carryover requirement in 524.3 and 0.4. So hot water rinses between samples and efficient bake cycle is, really a great way to reduce and eliminate carryover between samples. The sample cycle time. So especially if you're a contract laboratory, where the more samples that you can run within a shift or within an analysis batch, the more profitable you can be. So running efficient purge parameters and GC oven profiles helps run more samples per hour. And that moisture control, that water vapor. If too much water is getting transferred to the GC, like I mentioned before, it can impact your sensitivity. It can cause analytes to co-elute, have really poor peak shape. Our moisture control system, TechMar's moisture control system, and optimizing dry purge and bake settings can really help reduce that water vapor. Choosing the create split ratio and the column for the analysis can also help greatly reduce water vapor as well. And as you can see on your right, I have a 10 ppb 524.2 standard with a zoom in of those first 4 minutes. So that is those 4 minutes of desorb. And the water is creating, a little bit of peak tailing, but we get a lot of help from the moisture control system. There's no co-elution, and as you can see, there's still some very nice sharp peaks, even with that 4-minute desorb. And lastly, lower detection limits. Whether you're at the federal or regional state level, detection limits are only getting lower. So cleaning up the system between samples and being able to sustain high sensitivity is very important. All right, and some tips for a successful drinking water analysis. First, a big advantage is choosing efficient purge parameters for your drinking water methods. The more efficient your purge is, the better the chromatography you will see, and hopefully the easier your analysis will be. So the vapor pressure is the pressure at which a liquid and its vapor are in equilibrium at a given temperature. So components that have a high vapor pressure will have a higher purge efficiency. So vinyl chloride and the other gases, they have very high vapor pressures. Solubility is the maximum amount a substance that will dissolve in a given amount of solvent at a specified temperature. So if a compound is very soluble in a sample matrix, the harder it will be to remove it from the matrix. So for example, methanol is very soluble in water and it has about a 10% purge efficiency. Temperature, so we can heat our samples to help drive them from the liquid or the solid phase to the gaseous phase. There is a trade-off though. The amount of water vapor that makes it onto the trap doubles for each 10 degrees C rise in sample temperature. So you need to make sure that you are improving or optimizing those bake method parameters to ensure cleanup between samples if you're going to heat your samples for analysis. Sample size. So a reason why you would want to increase your sample size would be to increase sensitivity, especially for those compounds you want to see at those really low PPT levels. The more of the sample that you get trapped, the more that is going to be sent to the GCMS. And purge volume, the longer that we continue to sweep that headspace away, the more volatile compounds we can extract from a sample. As purge volume and time are increasing, we do get to a point where the results start to plateau and then eventually you start losing response because the compounds are just getting stuck in the sorbent bed of the trap. So if you're able to adjust the purge volume in your method, you'll just need to experiment a little bit, find where your sweet spot is in purge time and volume. And lastly, the type of sparger that you use. A drinking water method, typically using a fritted sparger, but there are also fritless spargers for those unfinished water samples. So using a fritted sparger creates a lot of small bubbles, which introduce more surface area for that liquid to gas interaction to occur. And this leads to a more efficient purge. Sometimes that fritted sparger doesn't work for your matrix. It doesn't work to your advantage, especially for samples that have a lot of sediments, like those wastewater samples we were talking about earlier, or raw influence samples if you need to test those, which can clog up the frit. So in that situation, you would not want to use a fritted sparger because that can cause a lot of carryover and contamination from sample to sample. In that case, we do suggest that fritless sparger. It does create larger bubbles, but makes it not as efficient of a purge, but it still gets the job done, and there's less concern for you of contamination and carryover, which can save you a lot of time cleaning up. All right, and then just a few tips for your drinking water analysis, kind of just like your wastewater analysis, that moisture control, that moisture control system that Techmar has in our products, it plays a big part. It helps remove moisture from the sample before it's sent to the GC for analysis. Like I mentioned before, we can also remove moisture from sample to sample by choosing efficient bake parameters on the GC side of things. We can adjust that split ratio. If it's set too low, too much water is getting onto that column, and that's going to cause a lot of issues with your chromatography. The Techmar number 9 trap, it's sent out with all of our units. It's a great trap for those standard EPA methods. We specifically, worked with the company that manufactures them, and, just to make sure that it helps our customers, with those problematic compounds like bromomethane. And efficient trap heating and cooling. So you want to make sure that your trap heater is reaching temperature to make sure that those target analytes are desorbing off the trap properly. You can double check this on your status screen on TechLink, on our software. If the trap isn't getting to temperature, then you might not be getting everything off the trap, and that could be why you're having issues like low recovery or carryover. Right? And GC column, by using shorter narrow bore GC columns, we can adjust that split ratio. So again, we want a higher split, and that allows, less of that moisture to get onto the column because it's going off to vent. Right, and then some shared features of our Atomics XYZ and our Lumen Aquatech LVA that will help you with these analyses. So both of our units have that improved trap box and trap oven design for easier trap changes, faster trap cool down time, which will help with your sample cycle time. The moisture control system fitting, which reduces the moisture or water headed to the GC. The solenoid valve manifold, which has fewer plumbing connections, making troubleshooting easier. And lastly, the electronic mass flow controller, which allows for independent programmable flow control in all modes. When dealing with active polar or high boiling compounds, it is important that the sample is contained in an inert sample pathway. So both the Lumen and the Atomics XYZ utilize inert tubing and treated fittings throughout the entire sample pathway. So this just ensures resistance to corrosion and prevents loss of compounds. So we've talked today mainly about our water wastewater category of our Purge and Trap methods, but you can choose to Techmar Purge and Trap by the method. So another major category of methods would be soils and solids. So our water methods can be broken down into drinking water and wastewater, like we talked about today. Do you need the capabilities of an in-vial purge because your wastewater samples are full of particulates? Or can those samples, be able to use a sparger purge? If it is a wastewater sample that's more liquid, that doesn't need dilutions or methanol extraction, then that can be performed on our Lumen Aquatech LVA. For traditional sparger purging, does the method require chilling or not? The Aquatech LVA has a chiller plate that comes standard, and it is an upgrade on the Atomic XYZ. And for the soil and solids methods, can be further broken down into low-level samples, which are typically purged directly in the sample vial, and then high-level samples, which need to be diluted through methanol extraction. These methods are done on the Atomic XYZ, where methanol extraction and dilutions come standard. Do you have samples that'll foam? The antifoam eliminator is an upgrade option for either system. So bolded methods listed below are the methods performed by our Lumen and Atomic XYZ that we went over today that are in the 40 CFR Parts 136 and 141. And for the Lumen to perform, like 624.1 for those wastewater samples, the sample matrix really needs to be more of a liquid matrix, but it can be done. So just knowing your sample matrix is really important in deciding which Purge and Trap you should use for your method. And then, of course, any type of solid matrix, you'll want to use that Atomic XYZ. So thank you so much for taking your time to join me today. Please check out our website for all of our latest application notes. You can also view past webinars, and be sure to visit our online store. You can follow us on social media too. And also, if you go to our website in the brands drop down, click on Techmar, go to News and Events tab and Promotions, scroll down, and you'll find our Purge and Trap entry form, so you can submit for your chance at our Purge and Trap /auto sampler giveaway, celebrating our 50 years of Purge and Trap. Also, please submit any questions that you have, and I'll be able to get back to you by email. So thank you. Have a great day.